The tension force is 5 newtons. Let's show the tension force like this. The tension force is 5 newtons. What horizontal force should this person apply by to hold this object, and the object, the mass of the object is 3 kilograms, and of course we know the G is 10 meter per second square. So in order to find this force, the horizontal force that the person is applying, we have to draw all our forces and find the forces that we need. In here, for example, we have the T. T equals 5 Newton. We better divide the T to its components. We draw perpendicular to the x-axis, and this would be the Tx. We draw perpendicular to y-axis, and this would be our Ty. The object is supposed to be held. Therefore, the forces must cancel each other. So the mg must be equal to the Ty. They should cancel each other. And the horizontal force must be also equal to the Tx. This is the F that we are looking for. This is the actual horizontal force that actually this person, because the blue person is applying it, let's draw it blue actually. Yes, this is the F that we are looking for. So, something important I'd like to tell you is that once I divide the T to its components, these two components, the Tx and Ty, are doing the same thing as T would do. So the T doesn't exist anymore because we are using its components instead. So the T, I'm going to make it dotted. So, you know what I mean is that I am not creating new. I'm not creating new forces. These are the components of T. So these two components are taken into consideration instead of T itself. Even though the T is still in the picture for us to help the calculation, but right now these are the forces that are facing each other. Right? So. This is what I am trying to find. If I find this one, I have found my answer. For now, I actually have the mg, which is, we're going to find whatever we can to get to what we want. The mg is 3 newtons. So this is 3. Therefore, this one is also 3. So this is also 3. And since this one is 3, if you look at this rectangle, you can see that this is also going to be 3. I know that this is 5, right? This was 5, right? The T initially was 5. This is 3, and I have a right angle triangle in here. I can easily use the Pythagorean theorem to find the Tx, and then I will find what I need. So I'm just going to write down what I said. Of course, Ty equals mg, therefore equals 3 newtons. I know that T squared, this is Pythagorean theorem, equals Ty squared plus Tx squared. Ty squared plus, this is Ty squared too, I mean it's equal to, and this is Pythagorean theorem, it tells us, but always this is the case, because in every time you divide a force to its components, to x and y components, you always are faced with a right angles, and you're always facing with a Pythagorean, you can always use Pythagorean theorem. So this is always the case, and it's mentioned previously in our math videos. So we have this one, and we can easily find what we need. So 5 squared equals 3 squared plus Tx squared. 25 equals 9 plus Tx squared. So Tx squared equals 25 minus 9. So Tx equals 16 radical 16. So Tx squared. So Tx equals square root of 16. Therefore Tx equals 4 newtons. Since the Tx is 4 newtons, I actually found the F that I'm looking for. I know that F equals Tx, so F equals 4 newtons, and this is my answer.